All right, so we reviewed oxidation numbers. The transfer of electrons is known as redox reactions, right? Reduction oxidation reactions. So remember your little kind of acronym here, oil rig. So this one stands for oxidation is loss of electron. And then the rig stands for reduction is gain of electrons. So let's take a look at an example. So we have solid zinc reacting with 2 hydrochloric acids to form zinc 2 chloride and H2 gas. So the first step to figure out what's getting reduced, what's getting oxidized, is to calculate the oxidation states of each. Here we have zinc. It's by itself, so it's in its elemental form, so it has an oxidation state of 0. Here we have H. It's with a nonmetal, so it is +1. Here we have chloride. It's a halogen, so it's almost always -1, right? It's not with oxygen. Here we have zinc. It's a transition metal, so it can have variable charge, kind of not really, but we'll pretend it can. And then each chloride here is going to have a -1 charge. You see the molecule is overall neutral. There's 2 chlorides, so that's 2 times -1. So to cancel that out, the zinc must be +2. And then we have H2 over here in its diatomic gas form, so that's 0. Next thing you kind of want to do is connect the dots of what's changing. So we can see zinc is going from 0 to +2. If it's going from 0 to +2, that means it lost negatively charged electrons, and so oil rig oxidation is lost. So this is oxidation. The other thing that changed is this hydrogen. It goes from +1 to 0. If it went from +1 to 0, it must have gained a negative electron. And remember, rig reduction is gain. So this is reduction. And then the chloride hasn't changed. It's -1 on both sides, so nothing going on there. Another thing you want to pay attention to and remember, reduction/oxidation. Both of these refer to what is happening to the molecule of interest. Right? In terms of the zinc, oxidation is occurring, right? Because it is being oxidized. However, we have another set of terminology called the reductant/oxidant. And when we say reductant/oxidant, we're referring to what the molecule of interest is doing to other things. So for example, this zinc here is undergoing oxidation. It is losing electrons. Those electrons must be going somewhere else, and so wherever else they're going, they're reducing that atom. So zinc, while it is being oxidized, it is acting as a reductant. And vice versa for the hydrogen, right? It's undergoing reduction, so it's gaining electrons. Well, it's got to be taking those electrons from somewhere, so it's oxidizing somewhere else, so it is an oxidant. So make sure you're kind of familiar with this stuff. It should all be review. And then the last thing you want to review is balancing chemical equations in acidic/basic water, and do that on your own. It's 17.1 to 17.2 in your book using the half reaction method.